Hello everyone. In this video, I'm going to explain exercise 3.2 from the polynomials. The main things you are going to learn in this exercise is first finding the zeros of the polynomial, quadratic polynomial. Okay, through the factorization method by the graphical method. Graphical method is very easy and important. So for that method, you need to understand what is the shape of the quadratic equation and what is the occurrence, how the occurrence of the graph and all. Okay, we know the standard form of the quadratic equation is y is equal to ax square plus bx plus c. Okay, this is the standard form of the quadratic equation. In this, always we should make sure of saying a should not be equal to 0. That is the condition. A, B, C are the real numbers here. Okay, they belongs to real numbers. Okay, when you draw graph for the certain x and y values, okay, you are going to get a shape parabola. Parabola, what it is? Parabola. Parabola is nothing but a U shape. Parabola is nothing but a U shape. See, for example, if A is greater than 0, you are going to get all the parabolas like upside curves. Okay, upside curves. This, if A is greater than 0 means A values are 1, 2, 3, 4, 5, so on, anything. So for that values, you are going to get the upside parabola. Okay, if A is less than 0, that means A value is a negative values like -1, -5, -8, like that. Less than 0, then you are going to get a downside parabola. Okay, next, one more thing. The curve cuts at x-axis at two distinct points. Means this equation is having a two zeros. Actually, every quadratic equation is a possibility of having at most two zeros. That means two solutions, maximum. You may get sometime one solution, sometime no solution, sometimes two solution. The maximum occurrence of getting zeros are two zeros. Okay. So if the parabola is, the graph is, the curve is cutting x-axis at two distinct points. Okay, then you may think, you may conclude that it is having a two zeros. This equation is having a two zeros. If the parabola is cutting the axis at one point, then this equation is having a 1, 0 only. Okay, if the curve parabola is not at all touching or cutting the x-axis at any point like this, then there is no zeros, means no solutions for this for the equation, for the given equation. Okay, same way here. If A is less than 0, here this graph contains two zeros, and here 1, 0 touching at x-axis only 1 point, and here not at all touching the x-axis. That means no zeros for the given equation. Okay, this is about the quadratic equation. Suppose, what about the cubic equation? Cubic polynomial, not equation, cubic polynomial. Cubic polynomial standard form already I discussed in the previous video. What it is? It is ax cube plus b x square plus c x plus d. Right? Here a should not be equal to 0. Okay. So in this a, b, c, d are four coefficients, real coefficients. Okay. So for this, cubic polynomial will have at most three zeros. At most three zeros. Three zeros. Here it is having at most two zeros. Okay. So this much information is enough for solving the exercise 3.2. Let us look into the questions. The graph of y is equal to p of x are given in the figure below for some polynomials p of x. In each case, find the number of zeros of p of x. First graph. See, if you have a scene, uh, the line means it's a linear polynomial actually. There is no curve here, right? It's a linear polynomial. So this is not at all touching the x-axis. So how many zeros we will get? How many solutions? No zero. Zero. Zero only. No zeros for this. Okay. So they asked here in each case find the number of zeros. No zeros here. Since it is not touching the x-axis, never meet the x-axis. If you see this second graph, it is meeting the x-axis here, this point. So only one point. So it is having a 1 0. 1 0. And coming to this one, here it is meeting the x-axis at 1, 2, 3. So this is having 3 zeros. Okay. Next. This one, this parabola is touching the x-axis at two different points. This is having 2 zeros. Next, this is having 1, 2, 3, 4. We should check only how many times it is touching the x-axis. So it is having 4 zeros. And what about this? 1, 2, 3. So it is having 3 zeros. Okay. Let's solve the second sum. Find the zeros of the given polynomials. So they have a given 4 different polynomials here. We need to take down each and every polynomial and find the zeros of that. Remember children, for finding the zeros of the polynomial, take that polynomial, make equal to the 0 first of all. And then you can find easily. The first sum. Question number 2. First bit. P of x is equal to, given P of x is equal to 3x. For finding the zeros of the polynomial, take this polynomial and put equal to the 0. Okay. So x is equal to, when you transpose the 3 to the other side, 0 by 3. 0 by anything is 0. So x is equal to what? 0. Okay. So the zeros of the polynomial is 0 only. Okay. Zeros of the polynomial is 0 only. Second bit. Next. P of x is equal to x square plus 5x plus 6. Take this polynomial, make this polynomial equal to the 0 for finding the zeros of the polynomial. Okay. This is monic quadratic equation. Monic means x square coefficient is 1 here. So when x square coefficient is 1, we say that it is a monic quadratic equation. For this, how you can solve means take this number 6. Okay. So write all the factors in order. 1 6 is 6, 1 into 6. 2 table, 2 3 is 6, right? Next 3. 3 already exist here. So stop writing. So 6 minus 1 gives the 5, right? But you need a plus 5, positive 5 and a positive 6. Okay. 3 plus 2 gives 5 and 3 into 2 gives 6. Okay. So when you are multiplying two factors, you should get this one for the monic quadratic equation. When you are adding or subtracting, you need to get the middle term. So for that, these two factors are satisfying. So let's write. So x square, instead of 5x, what you have to do? 2x plus 3x. Take the factors 2x plus 3x plus 6 as it is equal to 0. Okay. Now, in these two terms, what is a common? X is a common. If you put x outside, 1x will be left plus, and here x already gone out, so 2 will be left plus, here what we can take out the common? 3. Factor 3 you can take out. 3 already went out, so x left plus, and 3 goes in the 6 2 times. Okay. So now if you have a scene, these two will be same factors. So write only one time because these two are common again. So write only one time. And the rest of the things make it as a factor. X plus 3 equal to 0. So these two are the factors. So now x plus 2 equal to 0, one value you will get. X plus 3 equal to 0, one value you will get. So x is equal to, when you transpose to other side, minus 2, and when you transpose the other side you will get minus 3. Therefore minus 2 comma minus 3 are zeros of quadratic equation, zeros of p of x. P of x is our quadratic polynomial. Okay, minus 2 and minus 3. See, when it is monoquadratic equation, so you need to take the constant term and write the factors and check which is suitable for which factors are suitable for this quadratic equation. When you multiply, it should be equal to the constant term. When you add or subtract, it should be equal to the middle term. In such a way, you need to write the split the middle term. Split the middle term with those factors and take the common. When you take out the common, again you should get these two factors should be the same. Again, one factor should be the same. Okay. Then by equating to the 0, you can find out the zeros of the polynomial. Okay. Let's see the third question. One more question. P of x is equal to x plus 2 into x plus 3. This is the question. So for finding the zeros of the polynomial, take the polynomial and equate to the 0. X plus 3 equal to the 0. Here already the polynomial is factorized. So simply you take first factor equal to 0 and the next factor equal to 0. So x is equal to, when you transpose other side it is minus 2, and when you transpose other side minus 3. Therefore minus 2 comma minus 3 are the zeros of the given polynomial. Zeros of p of x. Next, last bit. P of x, given p of x is equal to x power 4 minus 16. Find the zeros of the polynomial. For finding the zeros of the polynomial, take the polynomial and equate it to the 0. Okay. See, here only two terms are there. Middle term is not there. You can't do the splitting the middle term method. Here you need to apply some logic. See, this one is a perfect square. Can I write this as a 4 square? 4 square is 16, right? So this number also we will write it as a square number. So x square whole square minus 4 square equal to 0. See, x square whole square is x power 4 and 4 square is a 16. So how this is looking like? This is similar to this formula. A square minus b square. So the algebraic law for this a square minus b square is a plus b into a minus b. So separate the factors. So this is like a square minus b square. So we can split this as a plus b into a minus b. This is it. Let us take it as a, this is a, this is b. So how can you write x square plus 4 a plus b and a minus b? X square minus 4, which is equal to the 0. Let's take the first factor and make it equal to the 0. Okay. Next, let's take the another factor and make it equal to the 0 for finding the x values. So now if you have a scene, x square is equal to, transpose the 4 other side, x square is equal to minus 4. Right. So x is equal to square root of plus or minus square root of minus 4. Okay, this is imaginary value. Under the square root, if you have a minus, this is imaginary value. So don't disturb with this value, keep like that. Now coming to here, this is like, again, we can write it as a x square and this is 2 square equal to 0. A square minus b square, right? A square minus b square means we can split this as a plus b into a minus b. So x plus 2 into x minus 2 equal to 0. So again you can write this as a x plus 2 is equal to 0, comma x minus 2 equal to 0, which is x values are minus 2 here and here x value is a plus 2. Therefore, zeros of the polynomial are minus 2 comma plus 2 comma plus or minus square root of minus 4 are zeros of polynomial. The given, if you have seen the given quadratic polynomial, it's not a quadratic polynomial, it's having a power 4. So at most you will get a 4 zeros for this polynomial. That's the reason we got minus 2 plus 2 and plus square root of minus 4 and minus square root of minus 4. So these are the 4 zeros of the polynomial. It's not a quadratic polynomial, children. Thank you. For the graphical based questions, watch my next video.